All right, so today we're going to be talking about Kubernetes and more importantly, Istio. And we're going to be talking about this in the form of what do you get with Kubernetes? So I'm going to assume a few things. One thing that I'm going to assume is that you guys know Docker. So make noise if you know Docker. Make noise if you like Docker. Okay, I want to see if there's going to be a radical difference there. All right, the next thing is, what about Kubernetes? How many people have used Kubernetes? Show of hands and noise. Fantastic. So I'm not going to give a big deep dive into Kubernetes, but we will be using it to show off what Istio is all about. So I'm going to probably cut my video now because it's going to be mainly screen share and live demos. So if anything goes wrong, it's probably the internet's fault, not mine, okay? What we're going to talk about today is mainly Istio. And today, Istio's goal is to make it easy to do all of these things, right? Have policy between your applications, observability. Think about security in kind of a way that's per application instance, and also start to think about reliability. Now, all of these things you could do totally without Istio. And for most people, that means code changes. So we're going to look at how Istio takes a different approach by using what we call the sidecar pattern. And if you used Kubernetes before, you know that you can deploy one or more containers together in what we call a pod. So we're going to see how we use that particular concept to add functionality to our application stack. So just a level set, when I think about all of these puzzle pieces, Docker, Kubernetes, and now Istio, I think people are really just trying to build a platform as a service. But there's only one requirement in building your PaaS. Anyone know what that requirement is? Yell it out. Right? Most people are happy with the platform as long as they built it. And the truth is, there's good reason for this, right? We always say, hey, don't reinvent the wheel. But the truth is, most PaaS, most platforms as a service don't necessarily do everything you want. They may get you to 70% or 80% use. But it turns out that you usually have to do a lot of glue code around it to actually fit the way your team currently works or adapt to the applications you're currently building. So think about these things as more pieces to the puzzle that let you build a better platform versus grabbing one off the shelf. All right, so most people believe the infrastructure looks like this. Everything is all orderly. Some developers believe this, that the ops people have everything in order. You just write apps and people will ship them, okay? Now, every once in a while, you may have a few issues, but most people think that their infrastructure has this kind of harmony to it, where everything looks the same and is very consistent to deploy. When we started building these platforms, I guess with these newer tools, most people have tried to figure out a way to package things, right? And we all know this story. You go grab something like Docker, and that allows us to establish kind of a better contract, regardless if you're writing Python or Go, something on the JVM. The goal really is to say, hey, let's package that in a single packaging format, regardless of the OS, if you're using different Linux distros or language. We have something that we can actually do repeatably. So this is where I think the container becomes important, right? So we're really talking about our app, all of its dependencies in a tarball. This works really well on a laptop or a single server. And then people start to say, how do I kind of run that application and manage it across lots of machines? And this is where people start looking for other tools. And there's awesome collection of tools like Nomad, Mesos and Marathon, and also tools like Kubernetes. Now, the thing with Kubernetes is it tries to take your container images and gives you an application API that says, hey, it goes across all your machines. Now, Kubernetes does give you some things that you need for reliability, like making sure that your app is always running. It does collect some metrics, at least the metrics the kernel knows about. This would be CPU, memory, maybe how often it's accessed, but not really the details you would expect from the application layer. So most people get to Kubernetes and they start celebrating. If you've ever run Kubernetes in production, make noise. All right, is it complete? Do you feel that you have 100% complete platform? More than likely, you don't. So if you think you do, you probably have some gaps. And most people, when I talk to them, after they get Kubernetes running, they often talk about visibility. Okay, where's all this stuff, right? How do you manage secrets at a detail level between the applications? One of these logos here is Prometheus. Like, how do you get some details about the request? Maybe, how many success or failures. You may also have custom metrics. Application tracing. So, recently, most people have discovered tracing their applications, right? You come in through one app and maybe it talks to 5 different apps before it can return a request. Most people don't have application tracing in place, mainly because it's really difficult to really instrument every app. And some people just don't want to do it just from the cosmetic aspect of it, right? You have these functions that are like 6 lines long. They do a specific thing and they're done. When you add metrics and tracing to it, your 6-line function turns into 25 lines. And believe it or not, it's like from a psychology standpoint, most people would just not do it if they had to add that much code. Now, the last logo on the slide to the far right or left, depending on how you're looking at this, is a logo for a project called Spiffy. Now, this is something I've learned recently, is the application's credentials. We always think of this app needs access to the database, and we tend to push those credentials to a server. So we tend to overexpose our secrets because we don't really have an identity for each process. Like, the goal should be each process has its own unique ID in a way that we can identify it in a way that we trust. So the Spiffy project attempts to say, let's do this with TLS certificates. Every process that comes up on the network, we'll give it its own ID, and we can use that ID etched into the certificate to provide it access to other resources like databases and other applications. Now, we could also give it username and passwords, but those will be assigned to the identity of the app, not necessarily the server. And all of this stuff that we try to do requires code changes for the most part. So what we want to think about here is, how do we do this in a way that we can do it across languages, across teams, across organizations in a sane way? So that's what I'm going to try to show you guys today. I would have a lot more slides about Istio, but you can get all this information on the website. I'm going to navigate that website a little bit so you know what we're talking about, what we're covering, and when you go and investigate yourself, you'll see what this stuff means. So on the Istio website, we have a bunch of things around tasks and concepts. And if you look at the overview, it kind of tells you what the goals of Istio are. And I'll go down here to this diagram here. So what we see at this diagram, Istio itself is constructed a lot like Kubernetes. There's a control plane. There's agents that enforce certain policies. In Kubernetes, we talk about what to run. And in Istio, we talk about how to protect and secure those things that are running. So when we look at this, we talked earlier about the sidecar pattern. So what we're seeing here is a pod that has your application indicated by service A and service B. Those two things have a sidecar process that is co-deployed side by side. Now, this Envoy thing can also run on the edge, and it will replace things like Nginx and HA proxy. Why would you do that? The main reason is that Envoy has the ability to integrate with service discovery, Kubernetes service discovery, console, or etcd. It knows how to do things to proxy gRPC, HTTP 1.1 and HTTP 2. It can also reverse proxy things like databases. So the idea here is that you can put Envoy in front of all your applications and databases and then start to inspect traffic as it passes through things. And we can get it to do some really cool stuff here. This middle piece called the mixer, once you have all this data flowing between your apps, we can actually get some attributes from the runtime itself. So in Kubernetes, we can get things like the application's IP address, its namespace, its environment, and other attributes that you may have put in place around annotations or labels. That data is attached to the actual input and output stream going between apps and sent up here to the mixer. Now, the mixer is responsible for saying things like, if you see an HTTP request between 2 applications, well, you can take that data and throw it into Zipkin so we can have visibility. Or you can automatically push it to Prometheus. Now, the nice thing about this is that the application developer doesn't really have to write any code to get this functionality. So with this diagram in mind, we're going to walk through deploying an application in Kubernetes using Istio and see what we get once we do that, okay? So I'm gonna switch over to my terminal now. Make noise when you see it. Thank you, guys. Flying blind here. All right, so what we got here is a couple of nodes in my Kubernetes cluster. So for those new to Kubernetes, the goal here is that even though we have these 6 nodes in my cluster, they're about 8 CPUs each, maybe 32 gigs of RAM. But the thing is, we don't want developers talking about individual nodes. So of course, it abstracts away some of the machine stuff. Really what we want to do is talk about people deploying applications. Now, before we get started with our app, we want to make sure that we have Istio installed. So here, I'm just going to list all the components installed. You'll see here, there's 5 components to Istio. That kind of makes up that control plane. This ingress part, if you have any experience with Kubernetes, this will replace the load balancer for your services. So if you're in Amazon and you're using Kubernetes and you created a service type load balancer, it will create an ELB. What we get with Istio, though, is that smart proxy that we just talked about, the Nginx and HA proxy replacement, you can just run that in your cluster. The nice thing about this, if you're in a cloud, you still can have like an L4 load balancer, like an ELB or Google's Cloud Load Balancer. In front of this, you can have HA, but you can have the same load balancer on-prem on your laptop and inside of the cloud. And this is Ingress is built on Envoy. So this is the sidecar process that is run at Lyft, which is the ride-sharing company. They do about 1 million requests per second in production for the last 2 years. So we believe it's pretty battle-hardened and tested. This CA will mint certificates for each of your applications. So what will happen here, when your apps come up, they will get their own certificate and it will be pushed down to its sidecar. And it would also rotate those certificates, so they'll be short-lived. And what you'll end up with is TLS mutual auth between all of your components that can also be used for authentication. We use Grafana as a default dashboard. We have Prometheus to collect metrics. And we have things like Zipkin to show us our application tracing. The next thing we need to do is get our app together. Now, here's a tricky thing that you got to understand about Istio today. Today, we have to inject that sidecar. You could do it manually ahead of time if you know what to put there. Or you can use a tool called kubeinject, part of the Istio command line tool, to wrap a sidecar there. Or in a future version of Kubernetes, 1.7, current version of Kubernetes is 1.6. In 1.7, you'll be able to have this happen on the server side. So when you see me doing things here, just know that the workflow will improve. All right, let's look at our Kubernetes application really quick. So if I say, I'm going to cap my Kubernetes deployment here. We have a front-end piece. When we look at our front-end, this is a Kubernetes deployment object. And here we just want to deploy the front-end container. And the front-end container will talk to 2 backends, bar and foo. And it will also have its own health checked IP. So if I want to health check the application locally, it does support gRPC and HTTP. So the goal here is that we need to deploy this with Istio. There's only 1 container right now inside of this pod. What we want to do, though, is have 2 containers, that sidecar that will implement all the policy and instrumentation for us. So what I'm going to do now is show you the Istio kubeinject command. So if I say istioctl kube inject, and then we're going to point it to that deployment config for my front end. We'll use the Kubernetes API library to read this file in and rewrite it with the sidecar in place. So we're going to run this now. And when we look at our output here, you'll see in the array, we have a new container here. Okay, so that container is the Istio container. It has a few flags here. It's going to run in proxy mode, sidecar feature, and it's going to pass through the health checks. It gets a bit of data from Kubernetes, like the IP of the pod, the namespace that we're running in, and the name of the pod. So this is enough so that we can get things like a unique certificate for this particular deployment or container. And then we'll also get our certificates from Istio, and we're going to mount those into place here. So with all of this in place, we can just push this to Kubernetes, and it will run. So let's do that now. So we're going to take that, and we're just going to wrap it in kubectl, apply -f, the result of that command. Again, this will move to the server side in the next release of Kubernetes. So in that case, you'll be able to say, I will like this particular application, sidecar or envoy attached to it. We'll run that command for the front end. We'll run the command for the back end, bar, and then we'll run that command for the other back end called foo. All right? And once that's complete, we'll see those being deployed here. All right, so we see bar, foo, and the front end. Now at this point, our application doesn't really know that Istio has been attached. My application can still use the built-in service discovery. So when my front-end app here wants to talk to the back-end bar, it will just call bar.service.whatever and assume that DNS will take over, even though Istio will hijack that traffic and give us stuff. Now, once we have that in place, we can create a service. So here we can create an ingress service. And this is this normal Kubernetes code. And here's where the integration between Kubernetes and Istio kicks in. By using this annotation here, ingress class equals Istio, the Istio ingress controller will pick this up and start to reverse proxy for our front end. So right now, if I want to hit our application on the HTTP interface, I can just call the ping method. That's already in place. We'll get this IP, so get ingress. So here's the IP address that will point to that reverse proxy running on the edge of my cluster through Istio. So what I'm going to do now is call curl. So we'll say curl on ping. All right, great. So we're talking to our front end. And we see that the front end is talking to V1 of our back end, of bar and foo. And what I'm going to do is put this in a loop here. So we'll just do a watch here, watch-x. And then we'll do curl dash silent. And then we'll put the IP here, and then we'll do ping. All right, so we see that this is flowing every 2 seconds. So what's happening now is, as I go in through my ingress controller, it's going to route it to my front end, and my front end will pass all traffic through its sidecar to bar, which will go through its sidecar. By doing that, what do we get? So let's pop over to our dashboard here. So now that those sidecars in place, without doing anything on the app side, we start to see that we get data inside of our dashboard. So this is feeding off of Prometheus, and it's drawing all of these graphs here. So when we look at this, I'm going to refresh this a bit. Let me refresh. We'll start to see some data coming from all of our services. You notice here we're getting data from our bar service, foo, and our front end is somewhere here as well. So this is all the data being captured from the sidecars and being pushed up, and this is where the mixer comes into place. The next thing we get is tracing. So with the sidecars in place, we also get traces. So if you look at here, we see that we get 3 spans. The first one is our front-end service. And then our front-end service is sending a request here to bar. Let me try to make it a little bit bigger. So coming through our front end, we then hit bar, and then we hit foo. And from this output, you can see that we're doing all of this serially, right? So for people checking performance in their application, maybe this will tell us the idea that, hey, Trace, we should be able to talk to these backends in parallel instead of doing it asynchronously. Maybe we can go async and talk to them and get the latency down for our requests. So once we have our Zipkin in place, we also have our Grafana data. We also get the topology of the application. So here, if I run this command, so this is a service called service trace, it will automatically paint this diagram of our application deployment. So it's telling me that the front end is talking to the bar and foo backends. And you can see the queries per second here, right? We're not going really fast. And we also can get the JSON output of this as well. So this is what I normally use if I want to paint my own dashboards or visualize how this is all working and communicating underneath the scenes. All right, so we got that so far. Now, the other benefits of Istio is to be able to do things like traffic shaping. You can do things like decide which endpoints get to see what traffic. Or we can also put in policies that deny traffic. So what we're going to do now is we're going to put a deny rule. Right now, our front end can talk to the back end bar, but let's say we don't want that to happen anymore. With the sidecars in place, we can go under the covers and say, hey, you don't get to actually talk to the bar service. It's a little bit like Kubernetes. We have these definition policy files. And here's one to deny traffic. You look at this output here, you'll see this rule will say for any service, we can say we want to deny, and then we can pick a set of Kubernetes labels. So here we have deployed our app with a set of labels, app equals front end. I'll show you that really quickly. kubectl get pods, -- show labels. There's a bunch of stuff on the screen, but I'll highlight it for you. You'll notice here our front end has the label app equals front end. All of these labels and metadata I can actually use in my policy files. So here, go find all of these things in Kubernetes and then make sure that none of them can talk to some other destination. I'm going to show you that in a second. So let's put this rule in place, and we're going to deny access to the bar service. All right, so here's what we're going to do. I'm going to say Istio CTL. We want to say we want to create a new mixer rule. It's going to be global for the entire service mesh. Anything going to bar.default service.cluster.local. So that's the namespace in Kubernetes, which is our default one. We're going to add this rule. Now, once we add this rule, we'll see the sidecars get the new policy and push it down. You'll notice that my request is no longer successful. It went away. If we pop over to our dashboard here, we're starting to see that we're getting 400s and 500 errors. Our front end is no longer able to talk to the backend bar. So that's throwing things off a bit here. And we might also see some updated traces here. Let's check that out. Right, so we actually see issues, okay? And we see that our bar is actually having an error here in our tracing logic. And we're doing all of this by sending these configs to the control plane. Now, let's say we want to fix everything and we want to put that rule back. Well, we could do the traffic shaping by deleting that rule. Let's delete that rule. What will happen is the sidecars will now enable access from the front end to the back end bar. Things become successful again. We'll also see our traffic in the graph smooth out. And we'll also see that our traces should be back to normal. Yep, and we see all three spans are completing successfully now. Now, the power for this is that most people are trying to build these solutions that work across cloud platforms. But the biggest problem is with Kubernetes, while it makes it easy to kind of deploy everything everywhere, then you have to resort to a cloud provider specific things. Like on Amazon, you have to deal with security groups. You're dealing with firewall policies. And on-prem, you may be dealing with the whole. So this allows us to do all that granular traffic shaping by just using policy within the cluster. Now, the last thing I'm going to show you before I wrap up is this idea of canary patterns. So Kubernetes is pretty awesome. We can also do things like rolling updates inside of Kubernetes, right? Where we can say, hey, we have a set of pods running, kubectl get pods. If we wanted to have v2 of this bar service running, well, we could update the container image and then Kubernetes would roll them out to everyone underneath that service. But what happens if you want to roll traffic out to only 10% of your clients? Or you want to only give the new version to mobile clients? That's something Kubernetes can't quite do. So this is where doing this inside of Istio becomes pretty important. So I'm going to show you what it looks like in Istio to make these kind of policies. That's going to be a route rule. And we're going to have a rule that says we want to route all the v2 traffic only to mobile agents. So here's a config. It's called a type equals route rule. We give it a name. And anything destined to the bar service, what we're going to do is match some of these headers. And if these headers match mobile, well, all of that traffic will flow to v2. So let's put this in action. So we see our services running. We see that everything is going to the v1 back in here. What we're also going to do is put a few policies in place that make sure that everyone stays on v1. If I look at this bar, I'm going to say no matter what's deployed, it will always go to V1. Now, Istio also supports some other stuff like being able to do retry logic. So if you think about it, you always ask the developer, hey, if one of your backends isn't up, don't just fail or just log an error. I would like you to retry or respect HTTP timeouts as well. The nice thing is we can do all of that logic on the sidecar, again, without writing any applications. So let's look at what happens if we don't have any route rules in place. Everything's going to V1. We're going to deploy the new version of our bar backend using Kubernetes. And we're going to do the whole injecting again. We want our sidecar there. So now I'm just going to deploy bar V1 or bar V2. Right? We'll do that. So you do that, and it's initializing. It's getting the certificate, standing up the sidecar, pulling out all of our applications, and we'll have V2 online. Now, once you do this self-service thing, this is where people start to get in trouble. Look here. We're bouncing new customers between V1 and V2. Maybe that's not quite what you want. Maybe you only want to do a canary deployment where it only goes to a subset of users. It's hard to kind of pull this off in Kubernetes. You will have to create a bunch of services and do a bit of magic to make all of this work. But if we put a few policies in place, we can prevent this kind of mistake from popping up in our cluster. The first thing we're going to do is add those base policies to say everyone in this particular service will always go to V1 for bar. All traffic, no matter what, will be weighted 100% to go to V1 of the app. You'll notice here, this version tag. This is another label that we're putting on our deployment. If you put this label on your deployment, then we can actually shape traffic based on that particular label. Reference it here. So let's create those as well. So istio-ctl, create-f, istio, route roles, and then we'll do bar, and we'll do one for foo. As soon as those go into place, the policy will be pushed down to the sidecars, and there you go. We have full control of who gets to see V1 or V2. Now, this is what we want. But on the other hand, we do want some clients to see it. So let's change the user agent really quick. So continue to use curl. We'll come back here. I'm going to set the user agent to mobile. We have our mobile and our browser online, but they both see the same version. So we can fix that by adding yet another rule, okay? So the goal here, we only want the mobile clients to see V2 and the browser to be pinned to V1. So we'll look at this last thing that we want to do here. Istio-ctl, route roles, bar, dash canary. All right, so we see that we want to match on the header. This will take precedence number 2. And then we only want to route anything with this header or mobile header, user agent, and we'll always route to the V2. Notice here that we're able to control traffic deep into the service setup. We're not just limited to controlling the front end. We also can influence how the front end talks to its own backends by putting this policy in place. That's kind of the power of the sidecar. Since the sidecar runs across the infrastructure, anywhere you put this policy, it'll be respected by all the sidecars. You don't have to worry about trying to do this with a single reverse proxy. All right, so with that in place, let's put that rule in place and see what happens. Istio-ctl, create-f, istio, route roles, and then we'll put our bar.canary. With that in place, you notice just like that, it gets pushed down to all the sidecars, and all the sidecars running, or all the sidecars, when they see the mobile client ID or user agent, they get V2. And if you look at what's happening on the browser, it's also pinned to V1. So this is a nice way to show how these are working. And if we go back to our graph, since it's using the actual data, we'll see that it paints a new picture here. If we refresh this, you'll see that the front end depends on V1 and V2 of the bar service. So we kind of get this real-time update over topology. And with that, that's the end of my presentation. Thank you.